Okay, well, let me first of all let me add my welcome to Thomas's welcome. It's good to see you all here, wherever you may be tuning in from, whichever part of the world. It's good to have you here, and I hope that you can take something away today from the presentation and the demonstration, which gives an inkling into GitOps and what it's all about. So this is very much a taster workshop. In 2 hours, it's we can't cover everything. We can't go into enormous detail. But what we do want to do, as the workshop title suggests, is to give you a taster. And there's lots of different avenues that you can pursue from here to get more involved and to get more information and more experience with GitOps. Okay, I think we've got. Is it possible for people to mute their channel? Thank you. Okay, so what we're going to cover, we're going to really tackle the broad question: why GitOps? Where's it sprung from? Why are we even considering it? What's the reason that it's come about? And then we're going to lift the lid on what is GitOps, and we're going to explore some of the principles that kind of form what the whole practice and the model is. And then we're going to take a brief look at some of the tooling that's available out there. We're not going to go into enormous depth. There's quite a lot of tools that are available in the GitOps space. And the new ones are coming out all the time, and the existing ones are maturing and so on. But we're going to talk about two of the more prominent ones, just so we can get a flavour of what's actually out there. And then, as Thomas mentioned, we will get into a hands-on session. I'm going to do that in the form of a demo, but there are some instructions that you can follow along with as well, so that you can actually do this in your own environment and to get first-hand experience with it as well. So really what we're looking for you to take away today is an understanding of the key principles of GitOps, the benefits that are associated with its adoption, some of the common tools and technologies, as I've already mentioned already, and we're going to look at how we might implement a very basic GitOps pipeline on a Kubernetes platform to deliver an application working on Kubernetes. But before we do that, it would be very rude of us not to get acquainted with one another, to find out who each other is. So let's, by way of introduction, let's just introduce who we are. So for me, as you already have been told, my name is Nigel Brown. I'm a cloud native trainer. I'm also an author and a writer. I've been training with container solutions for over a couple of years now. You can probably tell by the lines on my face that I've been around for a little while, so I've had different roles in the past as well. But probably got into the whole sort of cloud native space when Docker was first getting going, was fascinated with the whole containerization concept and what that was doing for application delivery. And so haven't really left there haven't left the space since then. And I've enjoyed sort of getting involved in some of the technologies along the way. So in terms of container solutions, if you're new to container solutions and you haven't come across the company as an entity before, effectively container solutions are a consultancy that specialises in getting companies into the whole cloud native way of working. So not just about the technologies, which obviously are key and important because they underpin a lot of what goes on, but also actually from a strategic perspective as well, because no transformation is built on technology alone. There is a lot of that needs to go on in terms of strategy, the way that you change the way your organization works, and so on and so on. So we try and do the whole picture effectively. We're a Kubernetes certified service provider and a Kubernetes training partner. These are things that are bestowed on container solutions via the Cloud Native Computing Foundation. If you're familiar with that organization, that's what, the home for Kubernetes and many of the other open source technologies that drive the whole cloud native space. And they work with organizations to get them to affiliate in terms of their capabilities in these areas. And CS are also a Linux Foundation authorized training partner. A lot of what the company does, especially in terms of its training, is to try and take what it learns in the real world by working with its clients and tries to embody some of that into our training as well to try and make that experience as real world as possible. And certainly the GitOps Essentials workshop that we do, which is really an extension of this taster, is built on that whole thing. And it's a very interactive session, and that's how we try and bring the real world experience into our training. So in terms of the education, we do all the standard stuff. We do Docker, we do Kubernetes, help people to acquire their certified Kubernetes application developer and administrator certifications. We train with Istio, we do GitOps, and as I've mentioned already, we also try and do the whole picture as well. So we do some more strategic type things. So we have a patterns workshop, cloud native patterns workshop, and a cloud native leadership workshop as well. So it's not just about the technology. We also try and help organizations, their management teams and so on, get the strategy right to achieve a successful transformation. Okay, so that's enough about me and CS. What we'd really like to know is a little bit about yourselves as well for you as your participants today. Very happy if some people want to unmute and say why you're here today, what your background is, and what is your experience with GitOps, and what you want to get out of this workshop. If you're more comfortable about doing that in the chat, then we're also, that's a very valid channel to introduce yourselves as well. So if you're feeling brave, then I'd love to hear a little bit from you to hear what your backgrounds are and your roles, etc. Okay, I'm just gonna go ahead.
I'll be brave and start. Hi, I'm Matt Feivel, and
hi, Matt.
I actually work at Google. Hey, and I work at Google. I'm an early Kubernetes fan. I work on the customer-facing team. I'm a partner engineering manager. But as a manager, I'm not doing much tech these days, so I was very excited to catch up on the latest cool ideas that are coming from container solutions in this space.
Okay, that's cool. Thank you. Anybody else feeling brave?
Don't know if feeling brave, but I'll go next. Hello, I'm Sebastian.
Hi, Sebastian.
Originally from Uruguay, working in Canada now for container solutions as a cloud native engineer, and very curious about the hands-on of GitOps. I read about it and I kind of did something in the past, but I was looking forward to this hands-on workshop.
Okay, cool. Thank you, Sebastian.
Maybe I can be the next one.
Thank you.
Hi, my name is Sevi. I am also a container solutions employee. I've just recently actually joined in, and it's been like over a month probably, and I've experienced some GitOps tools by myself. I haven't had the chance to work on them on a production level or with a client. Hopefully I will soon. So I just wanted to join in to see and have a hands-on experience in this workshop.
Okay, that's cool. Thank you, Sevi.
Thank you.
And there's a couple of people in the chat. Keelmath.
I can read them out.
Yeah.
So first to me, Thomas, so I also at CS as a cloud native engineer. I worked with plenty of clients facilitating GitOps and up until production. And it's always looking a little bit different, but the principles are always the same. And they're really nice. And yeah, they enable you to do great things with your implementation. And then we have a couple introductions in the chat. So we have Kedarnath, sorry if I butchered your name, from India, working as a DevOps engineer. So this is the right spot. Experience with Git, but not GitOps. So yeah, it's a good place to learn it here then. From Luna Sanchez, a systems engineer, working with Ops for 6 years now. Want to see GitOps in practice and a spotty internet connection. Yeah, hope it will work out. Then from Luis, from Mexico, a release engineer, and yeah, for personal experience, okay. And for work, we're using a weird thing called shared source control. I've never heard of that. We have a lot of static huge pipelines, which is not in the version control system. No experience with GitOps so far. Great, welcome. And then we have Odian or Victor from London, currently working as DevOps engineer new to GitOps. Hello and welcome. And then Ibro from Nigeria, software and DevOps engineer and a prospective cloud native engineer with container solutions. Oh,
okay,
hello,
that's cool.
and welcome. Great. And
excellent.
Another one from Rodolfo from Uruguay, working as DevOps in a development company with offices in Uruguay, Colombia, and USA, trying to include GitOps at our team. Great.
Okay.
And
awesome.
Another one. I'm Chaki from Tunisia, tech lead, certified CKID, and a little bit about GitOps learning it. Yeah.
Okay.
All
awesome.
Right. Back to you.
That's great. Thank you. Okay, that's great to get some feedback from folks and to get your backgrounds and where you're from in terms of your journey and so on. So so let's get cracking. So you can grab some materials. If you point your browser to this address here, you should see some slides, a PDF of the slides that we've got here today. And there's also a document which details the steps that we're going to follow later on when we use Flux to deploy an application to a Kubernetes cluster. So that's all you're going to need for today. So hopefully you'll be able to access the material at that URL. When we do get hands-on, you will need access to a Kubernetes cluster. You can use whatever you like. So you can use Minikube or Docker Desktop. You can use you can use a cluster from one of the cloud providers, and of course Google Cloud with GKE if you want to. But really, the key thing is you just need access to a cluster. So hopefully you'll be able to do that. But if not, you'll have the document to follow the steps in your own spare time after this event. And I'm also going to be doing this as a demonstration, so you can follow along there as well. Okay, so let's go. So let's pose that first question. What is GitOps? That's really where we need to make our start. And the first thing to say is that GitOps is a term that's been around for a little while now, since 2017, in fact. And if you think about the cloud native world, 2017 seems like an absolute age ago. It's only 4 years, but it feels like a lifetime in terms of the pace of change that we get in the cloud native space. And the term was coined by Alexis Richardson, who is the CEO of a company called Weaveworks, who are very prominent in the cloud native space. And he kind of coined it because it was best described a way that his organization were particularly working at that point in time. So that's where the or the term originated from. I don't know whether that's 100% accurate, but that's what everybody quotes. So there's no reason to not believe that. And there is a link here in the slide here to the blog post where this is discussed, so you can get a feel for what Weaveworks were trying to do at that point in time. And of course, GitOps is really a mashup or a portmanteau of two words, Git and operations. And it kind of has an echo of DevOps, which is a similar kind of mashup of terms where, obviously with DevOps, that means many things to different people, but essentially it was there to try and bring, or as a culture and a strategy to try and bring two different teams together so that they collaborate and work more closely together. And Git and operations is a kind of a similar thing. It's definitely something that's more oriented towards operations than development, but it gives, or rather it takes some things from the way that development teams work in terms of their flows and the tools that they work with and so on, and is trying to apply that into an operations-oriented environment, hence Git and Ops being combined together. And the other thing to say is that it also evolves the everything as code thing. So when we have infrastructure as code, if we really take that a step further, whenever we've got everything declared declaratively and so on, then we're trying to build on that whole movement that started with configuration management several years back, and is trying to build on that to provide a better experience for working with our applications in an operations setting. So here's an attempt at a definition. So GitOps is an operating model for both cloud native infrastructure and applications as well. So we mustn't just think about this as applications, because it can equally be applied to the infrastructure that underpins the applications as well. So here I'm talking about clusters and whatever else you might use, things that run in clusters that are there to support the running of your applications, etc., etc. And it provides for the management of infrastructure and applications using automation. So automation is a key aspect to this whole thing with GitOps. We're trying to remove as much of the human out of the whole delivery cycle or pipeline or workflow as we possibly can. And what we're trying to do is to establish a desired state, which we want to express declaratively as well. So those are the sort of broad principles that we're trying to operate when we're trying to describe and use a GitOps workflow. Now, some of you may be familiar with this face. This is Kelsey Hightower, who's very esteemed in cloud native circles. He's done an awful lot of work over the years to further the whole cloud native movement. And this is a direct quote from Kelsey. When he's describing GitOps, he's effectively saying it's versioned CI/CD, continuous integration and delivery, on top of declarative infrastructure. Stop scripting and start shipping. And I think the thing to take out of this really is that we're not trying to replace continuous integration and delivery, which are so key and essential to the whole way that we deliver cloud native applications, particularly in a Kubernetes setting. We're not trying to replace those things. We're trying to build on top of those things. They're still necessary, but we're trying to add some rigor and some capabilities on top of that to make it more robust and a better experience from an operational perspective. So why has it really come about? So we think about some of these things as sort of operational anti-patterns. So we may have, or you may be experienced with, certainly these are the things that would be happening in the past, that we would have manual deployments, often scripted, and we'd end up with a whole lot of code which quickly became spaghetti. Trying to unravel this would be very, very difficult. Whenever we were deploying new applications, we would have to rework these things to cater for new scenarios. And things are just not very flexible and very brittle by the very nature of what we're trying to do. And therefore things would break often. And quite often we'd find ourselves firefighting a lot of the time. This still goes on, I'm pretty sure, in a lot of organizations today. And so, you know, GitOps is one of these things that is trying to address this issue. In the past, we've had a lot of ad hoc state management. Okay, so the state that we think our system has is managed really according to best endeavors. Okay, so our state could be distributed across a lot of different sources. The ownership of the configuration could be according to different silos. So if teams work in different silos, they've got their own means of managing or storing their state and then managing that state. And whenever change occurs, there's no clear update process. And when you've got teams who are operating in silos, especially trying to communicate the change that occurs is also very, very difficult as well. So this is, you know, we rely on state being, you know, if we're talking about systems that are declarative and we need to know what their state is and what it should be, then trying to manage that state is absolutely essential and key. So ad hoc state management really doesn't help in that respect. Imperative changes. So if you work in production environments, and you have worked in production environments, I certainly have in years gone by, you know, when problems happen, as they invariably do, you have to change things because of operational issues, because you don't want downtime, you need to fix things quickly. So you will end up making imperative changes to systems. And as a result, you don't always reflect those back as new known states, particularly when you've got your state distributed across different sources, and some of that state is owned by different teams as well. So you've got no means of knowing who did what and when. There's no audit trail, if you like. So when you're trying to troubleshoot and unpick things, it's a nightmare trying to get to the source of the problem itself. So these are the things that GitOps is trying to address. So ambiguous state, configuration distributed across multiple sources, as I say, no clear ownership of configuration data, which then makes it harder to reason about the state in and between teams. Nobody's got a clear picture of what the state is supposed to be, and therefore you can't have a sensible discussion about it and plan your activities based on it. You may end up with configuration drift. So this is diverse. So even if you think you know what the desired state is, invariably your actual state will end up drifting away from that desired state, because the imperative changes that you make to the system, gradually there is a divergence. And that really means that the reliability of your system degrades over time if you allow that convergence to continue over time. And we've alluded to lack of control. We're unable to determine who's made changes and for what purpose. That sometimes means that it's impossible to maintain a secure environment because change is happening on an ad hoc basis. And particularly if you work in a sector where regulatory compliance is important, that's going to become an issue. If you've got auditors coming in to check your compliance and so on, and you've got ad hoc change going on your system, and you present your auditors with, well, this is what it should look like, and clearly your actual system doesn't look like that at all, then that's a problem. Does all of this sound familiar to people? Hopefully, this strikes a chord with people, because I think this generally is what people tend to experience. So GitOps really has been born out of that whole desire to try and get some control back, to be able to get a clear notion of what state is, and so on. So this has given birth effectively to the whole notion of GitOps. And GitOps is driven by a set of principles. So we're going to be taking a look at these. But what I'm going to say first of all, before we move into this, is to say that despite the fact that GitOps was coined as a phrase or a term back in 2017, there's never been really an agreed upon definition or set of principles or description which defines universally what GitOps is. And as a consequence, fairly recently, back in November 2020, last year, a group of people got together to create something called the GitOps Working Group. And its purpose was to promote skills and knowledge and competency in the whole area of the nascent field of GitOps, and to come up with a definition or a set of principles which could describe the whole field itself, so that we could have a common understanding of what it is. It is a technology and vendor neutral body, and initially it was backed by people like AWS, Microsoft / GitHub, Weaveworks, and so on. But since then, it has mushroomed into a much wider group of people with a vested interest from all kinds of different companies, both large and small as well. And they're busy working out what GitOps is. It's a work in progress. So I would encourage you, if you do have a genuine interest in GitOps and its direction, then you should pay special attention to the GitOps working group. And it's there is a GitHub repo called Open GitOps, as well as the GitOps working group repo. And the Open GitOps repo contains some of the documentation that the working group have created and maintained, some of the definitions and so on. And the GitOps working group is part of the CNCF as well. So you know, it's got some credence, and as I say, I encourage you to follow it. But in essence, this is effectively what GitOps is trying to achieve. We want to have a desired state. It may be defined in a Git repository. It doesn't necessarily have to be Git, but invariably it is, because Git is all pervasive generally these days, particularly in the cloud native in the cloud native era. That's where you would store your desired state. You would have a system, maybe Kubernetes, for example, which is running your applications and so on. And that is where your actual state is. And you would have something in the middle, which we've called here a GitOps operator, which is ensuring that what is expressed as your desired state actually is applied to the system as actual state as well. And it measures the difference between the two and takes action to try and converge the two. That in broad terms is what we're looking at. But if we were to look at some of these principles that have been defined by the working group as a work in progress, everything is version controlled. And what that means is that we have a single source of truth. So remember, we were saying just a moment ago that we struggle because there's no clear expression of state. It's not shared between teams and people. You can't reason about it, so on and so on. If we have a single source of truth, then that's something that we can all look at and we can share and reason about. And it acts as an immutable record of desired state. The fact that it's version controlled means that we've got different versions of our desired state. So we can look at the different versions as they progress from one version to another, and we can reason about those things. It's an immutable record, as I say. It's there for all time to go back to have a, to be able to inspect and to work out why things changed the way they did, and so on and so on. It gives us full history and an audit log. So that enables us, as I say, to look at the history and to be able to reason about what's happened and how you progress from one version to another. And as I say, Git is the modern day exemplar, but as I say, I think the GitOps working group is very careful not to place an emphasis on Git, the tool, even though Git is in the term GitOps. Any system that has the ability to store state and be versioned, etc., etc. In fact, one of the tools, which is Flux, uses S3 buckets as a potential source for its GitOps use. Declarative configuration. So desired state is defined using a domain-specific language. This provides the undisputed record of desired state. We can view this. We can view this as simple statements rather than complex logic that we might have in scripts and so on and so on. And declarative configuration is not new. When we talk about infrastructure as code and things like this, this is a concept that is not new and has been used for a number of years. And obviously with Kubernetes, we use things like YAML. With Terraform, we use things like HCL. There are new tools now where you do use logic, in fact. So if anybody has come across Pulumi, you can use the language of your choice, whether that's Golang or TypeScript or whatever it might be. You can express your configuration using programming languages that you're familiar with, and Pulumi allows you to then apply that to then apply to your system to bring about the desired state that you want to have. But declarative configuration is key. Automated delivery. So what do we mean by this? So here what we're saying is the declarative configuration that we have about our system, let's say Kubernetes manifests or Helm charts or whatever they might be, these are delivered automatically. Okay, so they're stored somewhere declaratively, and then they are retrieved and delivered to the system automatically. And this can happen either via a push or a pull configuration. We talk in GitOps terms sometimes in push terms or pull terms. In pull terms, you have something running inside the cluster which pulls the configuration into the cluster. If you have a push-based system, then your automation is outside the system and will push the declarative configuration to the cluster. Autonomous agents, these are things that apply the configuration to the system, and they also monitor the state of the system and attempt to maintain the state of the system on an ongoing basis. Okay, so it's one thing to retrieve the configuration, if you like, our desired state, but then it needs to be applied to the system as well. GitOps principles suggest that you should have autonomous agents to do this. But those agents must also then monitor the state of the system and work on the difference between the desired state and the actual state, and then bring that back in line again. And that's a familiar concept if you're familiar with Kubernetes, because that's exactly how Kubernetes works anyway, with its control pattern. And then, as I mentioned, closed loop. Delta between desired and actual state is measurable, and then action is taken to ensure that the actual state is equivalent to that desired state. Okay, so this is typically what a workflow might look like. And earlier on, I was mentioning that we're not trying to replace continuous integration and delivery. What we're trying to do is build on top of this, this whole concept. So this is just one way that you might want to pictorially represent a GitOps workflow. So here on the left-hand side at the top, we've got a developer or a team of developers who are developing the application. They're using an application repository, which is a Git repository in this case. And when they push their changes to that repository, that triggers a continuous integration workflow. So we might have a build of some artifacts, we might have some tests that are going on and all kinds of other things that might be a part of your continuous integration pipeline. But at the end of that, you might then build a container image, which then gets pushed out to a container registry. That is all pretty, I was going to say standard, but these things are fairly normal and typical in a cloud native environment. Maybe what you also would have is an operations team that have a config repo that actually have some Kubernetes manifests which describe how that application is then deployed into a Kubernetes cluster. So it might have some descriptions of deployments, services, ingresses, ingress rules, network policies, whatever it might be. There might be a whole bunch of stuff that actually describes how that application is then deployed into a cluster. If we've got a Kubernetes cluster here, our GitOps agent might be running inside that cluster. It might be monitoring that config repo, and every time, periodically, it will be syncing the content of that cluster, of that repo into the cluster to represent our desired state and to apply that desired state so that it actually becomes the applied state. Similarly, some GitOps tools are able to monitor container registries as well. So if they see new image tags for particular container image repos, then it can also pull those changes into the cluster and then update the config repo with the new version of the application. Okay, some people may do that, other people may not want to do that. Maybe you could configure it so that the GitOps agent actually makes that change but creates a pull request, and the operations team have to approve that pull request before it gets actually applied back into the cluster. So here you can see that the GitOps part of this is building on top of the continuous integration pipeline that might already exist. Okay, so that's really the principles that govern what GitOps is and how it works, but what are we actually looking to get out of this, and what benefits is it actually going to be providing for us? Well, it gives developers and operators alike some benefits. Okay, so first of all, we get some familiar tools and a familiar workflow to work with. That's particularly for developers. So they're already using Git every day as part of their working practice. They use workflows and continuous integration workflows as well. So these are all pretty familiar things. So we're not taking that away, we're just adding to it. There's less of a requirement potentially for developers to grok Kubernetes, so they don't have to be doing some, adding Kubernetes nodes and doing some of the infrastructure stuff that perhaps some of the operations teams might be needing to do. One of the things I think we hear quite often is that developers really just want a simple experience when they're developing with Kubernetes. They want to be able to develop their application. They want to see it deployed into a Kubernetes cluster. They want to see how it operates and works, and to be able to debug it and so on and so on. They don't really want to be dealing with building Kubernetes clusters and all of the stuff that goes with that. So GitOps does enable you to have a separation of concerns, so that people that are more suited to working with clusters can do that, whereas developers can work from an application perspective. And you can build self-service into Kubernetes using GitOps, and that obviously helps with increased velocity because there's less of a requirement for ops teams in particular to have to deal with many development team requests to give them access to this, that, and the other. And it gives obviously operators more time to focus on infrastructure. So we get we get improved reliability because we have less time firefighting with production issues. So we've talked about configuration drift. When or if there is drift because imperative changes that may be occurring on a cluster, Kubernetes cluster, for example, that's being monitored for on a constant basis when you're using GitOps, and potentially remedied at the same time as well. Okay, so that problem where we've seen gradual convergence from the desired state, from the actual state from the desired state, doesn't happen so frequently, and when it does, it automatically is converged as well. And that's because change is applied to the system by automation. As we mentioned earlier on, when you have humans in the loop, then there's potential room for error to creep in. That's not to say that GitOps is infallible, because obviously it isn't. But what we're trying to do is remove some of the inherent frailties that there might be. We've got a full audit trail, as we mentioned already. We've got that to inspect, which gives us, when it comes to troubleshooting, the ability to work out what's gone wrong where, because we've got a history of the change that's occurred on the system, and potentially it's easier to back out failed change as well, because everything is versioned and we know what changes have occurred. Hopefully, all of those things improve the reliability of the systems that we're trying to manage. Better consistency. So most teams will develop best practices, or most organizations will certainly develop best practices, which reflect the way that they work. And also these things come in the form of standards as well. Sometimes standards are imposed because obviously security is an important thing. We mentioned regulatory compliance and things like this also. So these things have to be there, and it's much better that, if there's a common understanding of system state. If we've got that, then we can reason about things, and we can configure things in such a way that consistency is maintained whenever we're rolling out applications, infrastructure, and when we're rolling out change to those systems as well, then we can ensure that that consistency is there. Change is effectively approved through pull or merge requests, so there's no ad hoc changes going on here. We've got gates in place to make sure that things are peer reviewed, and change is not merged unless there is a very clear reason that it's good to go. And in that case, we can obviously enforce things much more strictly, particularly the security through change gates and so on. Okay, let's take that's a very big, very quick whistle tour of the benefits, obviously, but we're going to take a look at some of the tooling that's available in this space now. So first thing to say, I mentioned that this is a young space and tools are coming out the woodwork all the time. Tools are in various stages of maturity and so on. And this slide reflects this quite neatly, in the sense that this was a technology radar, effectively a survey of the Cloud Native Computing Foundation community, and particularly those people who have an interest in continuous delivery. Back in June 2020, and basically it was, the various tools were categorized into 3 different categories. So there was assess, trial, and adopt. And the community would grade each of the tools according to what they thought was the recommendation for each of the tools, and the phase that they thought each of the tools was at. So a number of these tools were considered perfect for assessment, and you can see in here some of these things will be familiar with people. There's a couple over here in the left-hand corner here, so Argo CD and Jenkins X, who these are, when you talk about GitOps, these are two of the tools which pop up in conversations quite regularly. Argo CD is definitely one of the big players here. If you look into the adopt area here, you've got Flux here. This is another one of the big tools that is in this space, which we're going to be working with in a short while. But some of these other things are ancillary but important items that all contribute to the whole GitOps concept and the way that you work with GitOps as well. So these things are all pertinent as well. But this gives you a feel that, or a flavor at least, of some of the tools that are available, and also the perception about their maturity at this point in time. I find this slightly confusing, this slide, only because Flux has one version which is mature but is being replaced with a new version which is less mature, and so on. So you can see how things are changing all the time, and maybe if this survey was done today, it might be slightly different, who knows. So let's look at Flux. As I mentioned, Flux really is kind of in between things at the moment. There was a Flux one which came out of Weaveworks. It came from Weaveworks initially, had a lot of adoption, but then has been completely rewritten from the ground up, and is now version 2. So I'm talking about version 2 here. It's an open source project created by Weaveworks, as I mentioned, and you'll remember the word Weaveworks, or the company Weaveworks earlier on. I mentioned Weaveworks, who coined the term GitOps. This project is under the CNCF. It's constructed from something called the GitOps Toolkit. So the GitOps Toolkit is a separate project in itself, which is comprised of different components, and these things together combine to form Flux. So it is for Kubernetes. So basically, you define stuff in Kubernetes. There is an agent or agents, toolkit components which run in Kubernetes, and these are the things that perform the GitOps functions for us. But we'll say more about this shortly. So if you were to say for and against, this is very subjective. Flux has a workload image update feature, and so it's able to monitor container registry repositories for new image tags, and it's able to update the workloads, but it will first of all update a Git repository, but once it's updated that Git repository, that change is then reflected back into the cluster, and your annual workloads get changed as a result. So you don't have to tell Flux, or you don't have to make a change to a Git repo. Flux is able to do that on your behalf. It's arguable whether you think it's a good thing to have or not. Some people like it, some people don't. Flux can be bootstrapped using a CLI, which is great. I will say more about that in a while. We've already said that it's on the technology radar. It's a adopt status with that caveat that I mentioned. It's a CNCF incubating project, so a lot of cloud native tools are at various stages in their maturity and development. Incubating is one of those that is it's beginning to get started out and achieving some maturity and so on. So that's where Flux is at the moment. Against, you might say, is that it doesn't have a nice, pretty user interface. I believe there is a what's the word I'm looking for? There is a rudimentary experimental user interface as it stands at the moment, but I don't think many people know about it at the moment. This is in contrast to some of the other tools. And maybe against is also that it's not currently GA, although I know that people are using this in production already today. So this pictorially is how it might look. So the toolkit consists of a number of controllers. You have a source controller here, and this is what is responsible for retrieving the declarative configuration from remote sources, Git sources, Helm repositories, and S3 buckets and things like that. So that's the controller that's responsible for retrieving those sources, Those sources are defined by Kubernetes custom resource definitions, and we'll talk more about those in a bit. There is a customized controller, which is responsible for applying what is retrieved from the sources to the cluster. And that works based on a customization, custom resource definition. And then there is also a Helm controller. So if your configuration is expressed in Helm charts, instead of customized overlays or Kubernetes manifests, then Helm controller can apply Helm releases into the cluster from the sources as well. Okay, so there's a bunch of things that are running in the cluster, and they work off of these custom resource definitions in order to bring about the desired state. So Argo CD is the second key tool here. So description is that it's declarative GitOps-based continuous delivery. It's an open source project founded by Intuit and is based on something called the GitOps engine, not to be confused with the GitOps toolkit. At one point in time, Flux and Argo CD were going to be based on GitOps engine. They came together to work together, but then for some reason they have diverged onto separate paths again. But Argo CD is based on GitOps engine. And it's installed and managed completely in a Kubernetes native way as well, just as Flux is. Pictorially, this is how it might look. So here we have a Kubernetes cluster. There are a few components inside this cluster, which are provided by Argo CD. There's a repository service, so that's very similar to the source controller with Flux. There's an application controller, which is responsible for managing the state and so on. And then you have an API server here, which you can interact with using either a CLI or a graphical user interface. So if you are a user of Argo CD, perhaps you are pushing things to a Git repository, you might trigger a webhook event, which then causes Argo CD to reach out to the Git repository to pull the configuration into the repository, which then is applied to the cluster itself. There is also a REST-based interface for external tools to interact with Argo CD inside the cluster as well, which might be useful for people. And there is also a notification system, which Flux also has, by the way, for actually alerting people to certain actions on various different channels. So whether that's Slack, Discord, Microsoft Teams, things like that. And Argo CD also has the ability to deploy stuff across multiple clusters as well. So for Argo CD manages multi-tenant and multi-cluster deployments. There is centralized management. Yeah, it does have a nice user interface. It's backed by Red Hat and GitLab. So, there are some big companies that have put their force behind the Argo CD approach. If you believe that there is kind of two different ways of going, Argo CD versus Flux, or even Jenkins X, which is another one which we're not going to cover here today. So if you take stock by that, then you can take some comfort. There's some big backers there. Again, this is very subjective stuff, but heavyweight tool, maybe. It does have a fledgling image update feature, but it's not kind of usable yet, as far as I'm aware. The last time I looked, it was still very experimental. So just by way of summary, so Argo CD and Flux are two of the big players in this space at the moment. There are others, as I've mentioned. Jenkins X is another one, which is really more of a curated set of tools to give you a similar experience. There's another one called CubeStack. GitLab are developing something based on the GitOps engine, and so on and so on. So you can basically see that more and more tools will flourish in this space as time goes on, and the existing tooling is bound to be maturing over time as well. But pick your tools carefully and make sure you do a good reconnaissance of the space as it stands at the moment before you make your choices in terms of the tooling that is most pertinent to you. Okay, so we're going to take, where are we now? We're 5 o'clock. So we're on the hour. So I think we should take a 5-minute break, perhaps, and then perhaps we can reconvene in 5 minutes, and we will we'll get back to doing the hands-on, and yeah, we'll maybe take some questions as well at that point. So everybody okay to get back here in 5 minutes? Cool, excellent.
Sure.
Okay. Okay, see you in 5. Okay, how's everybody doing?
Trying to get all my GitHub access working again. It just goes long time between when I use them.
Okay, it was difficult to hear what you were saying then.
It's working.
Okay, so I think we'll we'll get going again. So let's just share my screen. Okay, everybody see my screen okay?
Yep, I think so.
Yep, good, excellent. So, so we're going to get some hands-on now. So in the short time we've got available, we can't do an enormous, huge thing, obviously. But what we do want to do is just try and give you a taste of what goes on and to see this stuff working in action. So what we're going to do is look at a simple GitOps workflow. We've got a simple application called PodInfo, and it's packaged as a Helm chart, which is obviously stored in a Helm, well, say obviously it could be in a Git repo, but it's stored in a Helm repository. And it's this that we want to get deployed into our cluster. And we're going to be trying to do this without actually typing kubectl apply or Helm install or whatever method you might use to install to a cluster. So the steps that we're going to follow are we're going to bootstrap Flux into the cluster. So if you have your cluster, then we can follow the steps, or you can just watch me do this demo, and maybe you can you can follow the steps in your spare time. But we're going to bootstrap Flux in the cluster. We're going to create some custom resource definitions for the PodInfo app that are specifically relevant to Flux. So custom resource definitions that Flux understands. And then we're going to observe the app getting deployed to the cluster from a Git repository. We're then going to change the app's configuration in Git, and then we'll observe Flux making those changes in the cluster or reflecting those changes as the new desired state back into the cluster. So as I say, we're not going to be, we might be typing kubectl, but we won't be typing kubectl apply. Okay, so we're going to be letting Flux do all of the deployment itself. So to follow along with this, as mentioned, you need a Kubernetes cluster, Minikube is fine, or whatever you've got. You do need a GitHub account, and you're going to need the Flux CLI. And if you look in the instructions, you should be able to download download the binary or install it based on your OS. So in the instructions, if you follow the link that was given to you for the materials right at the start of the session, in there is a link that takes you off to a page which tells you how to install Flux in your local laptop or workstation. Okay, so you can feel free, as I say, to follow along with this as you would like, or you can observe as I type commands and so on. Okay. Hopefully everybody can see my terminal windows okay?
Yeah, okay.
Okay, and as people are perhaps looking at installing the Flux CLI, I already have it installed here, so I'm just going to give you a quick feel for what it can do. So the Flux CLI, typically speaking, you would use this as a convenience tool, okay, basically. But one of the key things that you're able to do is to bootstrap a Flux instance into a cluster. If you think about this, Flux is, and other GitOps operators are there to manage applications, but they are applications in themselves. So we've got a bit of a chicken and egg scenario here. What comes first? Obviously, you can bootstrap or create a structure, maybe using something like Terraform or something like that, and maybe you can get Flux or Argo CD running in your cluster that way. But just for convenience here, we've got the Flux CLI with the bootstrap subcommand, and that enables us to bootstrap our cluster. And if I do a help on that command, you can see there are 3 scenarios here. I can Flux bootstrap Git, GitHub, and GitLab. And I'm going to be working with GitHub today. So what we're going to do, the reason why we're referencing GitHub here is because this bootstrap command will create a private GitHub repo, and it will create that repo and store the manifests for Flux, the toolkit elements itself. So that enables Flux to manage itself. So we'll do this, and then perhaps we'll see that this will become a little clearer as we execute the commands. If you're doing this, following this along, don't forget to create your a GitHub token and an environment variable, which are also in the instructions that are given in the materials. You'll need this because Flux CLI needs that in order to create your private GitHub repo. Okay, so well, actually, the first thing I'm going to do is just do Flux check, a pre-installation check here. Oops, help if I spell it right. Okay, so it goes away and it says, okay, well, you've got the right version of kubectl available. You've got the Kubernetes cluster of the right version, etc. So all's good. So let's go ahead and do the Flux bootstrap command. And so there's a couple of arguments we need to provide here. So I need to provide the owner of the repo, which is me. So obviously you would need to put your GitHub ID in there. It's not an organizational repository, it's a personal one. So we need to make sure that is reflected there as well. And then the final element is the name of the repository that we want to create, which I'm just going to simply call Flux. Okay, so if we run this command, a lot of things are going to happen. So hold tight and let's see what happens. So Flux has effectively gone off, created the repository on GitHub, it's cloned it locally, it's created the manifests, the Kubernetes manifests for the various toolkit components that make up Flux. It's installed those into a namespace. It's also created some sync components, some sync manifests, which I'll talk about in a moment. And then it's just checked that the various controllers that I talked about when I was talking about Flux earlier on have been installed, and it looks like that's all happened and is all pretty good. So let's just have a look inside. Let's come over here in this other window, and we'll have a look at what's been deployed here. And as you can see here, we've got a bunch of things over here. So we've got a Helm controller. Remember I talked about the Helm controller. We've got the customized controller, the notification controller, which I didn't talk about, and the source controller. So these are the GitOps toolkit components that make up Flux. And we've got a pod, each of those running inside the cluster at this point in time. So that's one thing. How about I mentioned that a GitHub repo had been created. So let's just have a look here too. Okay, so you can see, do I need to zoom here, Thomas? Is this readable?
Yes, I will link to it.
Okay, how's that? That better? People can hopefully see that.
Yeah,
So here's a brand new repo that's been produced 2 minutes ago. There is a folder in here called Flux System. And in here, there is a YAML file called GOTK components, that is GitOps toolkit components. And in here, there is a whole bunch of YAML which describes the deployments for the toolkit components, the services and the network policies, the namespace, and the various custom resource definitions that need to be registered with the Kubernetes API. So all of that is now in this repo. Plus also there is a sync YAML as well. And this is key here. There are two components in here. There is a Git repository source definition and a customization definition. These kinds, the Git repository and the customization, are custom resource definitions associated with Flux. And this Git repository custom resource definition basically is saying here, well, there's a URL here, which is the URL of this repository in GitHub that I'm actually looking at. And it's telling me that we're monitoring, the source controller is going to be monitoring the main branch, and it's going to be checking every minute and retrieving any change every minute. So that source controller is going to operate off this Git repository CRD in order to retrieve information that it needs to apply to the cluster. What gets applied to the cluster is defined in this customization, custom resource definition here. It references in the spec of the customization a Git repository, which is called Flux System, which is this thing above here, and it's got a path, which is the root path. So basically, anything that gets retrieved from this repository, this GitHub repository, onto the cluster by the source controller will get applied by the customization controller according to this customization CRD. Okay, so hopefully that makes some sense. And so we've seen that we've got all of these toolkit components running. So if I also do let's do oh, sorry. Okay, so what you've just been looking at in GitHub, that custom resource definition is already in the cluster because Flux, the source controller, has already retrieved it from the GitHub repo. You can see that it's the main branch and the commit that is actually the relevant one. So C258, and if I very quickly just go back here, I can't see that in here. Anyway, it is that commit. And similarly, if we were to try and look at customization, it also is in the system as well. So those things have been retrieved and they've been applied to the cluster. So that's the first part of the job done. Basically, we've just bootstrapped Flux into the cluster, and it's working, and it's managing itself by virtue of the fact that it's got these custom resource definitions inside the cluster. Now, the next thing I'm going to do is I'm going to clone that cluster, that repo, that GitHub repo that's just been created locally. That's so that we can make some changes to it. And we can push those changes back in order for Flux then to pick those changes up from GitHub and then apply them to the cluster. Okay, so if I change into the directory, and I'll do a listing of what's in there, you can see it just reflects what we've just seen through the web interface when we were looking into, on GitHub, and we can see the components underneath the Flux system directory. Okay, so that's the first part. So now what we want to do, we want to turn to our application. We've got Flux running in the cluster, it's managing itself, but now what we want to do is to make it aware of our application called PodInfo, and we want it to get that automatically deployed into the cluster. So if I create a directory called PodInfo, we are in the right directory, Flux directory, yes, we are. Okay, so now I need to create a new source custom resource definition to tell Flux where to find the Helm repository for our application. I could do that by hand, but instead I could use a handy way of doing it, and I can use the Flux CLI. But rather than just running the Flux CLI command, which would apply the definition straight to the cluster, I'm just going to get it to generate the YAML definition, and then we'll push that to GitHub instead. So let me just get my notes here. So what we're going to do, we're going to create a Helm repository. We're going to give it a name. This resource is going to have a name called PodInfo, because that's the name of our application. I'm missing something out here, because it's a source that we're creating. Okay, so it's and all we're going to give it a namespace to put this particular resource into. Going to get it to put it into the default namespace, and then we need to give it a URL. So just need to remember okay, let me just make sure that's spelled correctly. I reckon that's about right. Okay, but before we execute that command, as I say, I'm going to do an export. Okay, and what this does, if I do an export, then this is what gets produced. Okay, so as you can see here, we've got a Helm repository kind associated with the source, the Flux's source API. It's got a name of PodInfo, and then there's the URL. It's also got an interval here, which is how frequently the source controller is going to go out and check whether there's changes in this repo that it needs to go and collect. So I'm going to run that command again, but this time I'm just going to redirect it to a manifest, which I'm just going to call source.yaml, like so. And if I cut that file, there we are. There's our Helm repository manifest created. Now we need to get this to GitHub. Okay, so let's stage the changes, because if we just do a directory listing, you can see here we've still got our Flux system folder, but we've now got our PodInfo folder with our source inside it. So we need to get this change onto GitHub as well, because this is just local. So let's stage the changes, and then I'll commit this, and I'll just say define Helm repository source for for pod info. Okay, I should do. Okay, and then I will push the change. Okay, so now if we go back to our Flux repository, we can see the changes there now. So we have our pod info folder and our Helm repository source is there. Now that it's there on GitHub, and we know that the Flux's source controller is monitoring this GitHub repo, then in theory, the source controller is going to retrieve this new information. And we should see this reflected inside the cluster. So we can check to see whether that's actually the case. So let's have a look. And there it is. Okay, so so Flux has been monitoring the repository. We pushed our change there, and it's found this change, and it's retrieved and then applied our custom resource definition to the cluster. So this now is in our is within the cluster, and now our source controller is going to be monitoring this repository. Okay, so it knows all about the Helm repository where our chart is located. The thing is, it doesn't actually know about the chart itself. Okay, so we need to do something else to make this work. Okay, and what we actually need to do, you'll remember when we were looking inside the Flux system namespace, that one of the controllers here is the Helm controller. Okay, so that means that we should be able to apply configuration in the form of Helm charts, but we need to provide that information for the Helm controller to actually act upon itself. So guess what? We're going to be using the Flux CLI again to create a Helm release custom resource definition. This is another custom resource definition that that Flux works with, and specifically the Helm controller. So we can create, we can use the shorthand notation, which is HR for Helm release. Call it pod info again. Well, we'll use the name pod info again. Again, we're going to be putting this into the default namespace, because otherwise it would go into the Flux system namespace, and we don't really want to muddy that namespace with our application. Now we need to say this Helm release needs to refer to a source, and the source is of type Helm repository. Okay, and it's the one that we've just created, which we called pod info. So this is the syntax that you would use to reference a Helm repository source for a Helm release. Now, the other thing that we need to actually define is the chart that we're going to use, because Helm repositories may have a whole bunch of charts. In actual fact, this one only has one, which is called pod info, so that's all right. But we need to put that in there. And remember, in order to stop the Flux CLI just applying this straight to the cluster, and to get it to generate the YAML file, the YAML, instead we need to put --export. And if I run that, you can see that it creates a new CRD type called Helm release with the name pod info. The spec of this, which defines what it is, has a chart, and that itself has the name of the chart it's going to use, and the location, which is the reference to the source, the Helm repository source that we just created. Okay, so before we actually push that to our cluster, what I'm going to do is, because right now in our cluster, we don't have anything running. So what we should see when we push this to our GitHub repo, we should see everything retrieved from that repo, and then the Helm controller will notice the application of the Helm release, and it will go off and retrieve the chart, and it will get installed into the cluster. Well, that's the theory, at least. So so let's just see whether this works or not. So the first thing we need to do is stage. Oh, hang on a sec. What I didn't do is actually create this. So what I'm going to call this is podinfo/hr/YAML, like that. There it is. Okay, now it's in the right place. So if we stage that change, I'll commit the change and define Helm release for pod info. I should do. And then I'll push the change. Okay, that should be inside our cluster. And so now we've got our Helm release there in GitHub. And if I come back here, hopefully in a second, oh, there we go. So Flux has gone away. It's retrieved the Helm release definition. It's applied it to the cluster. The Helm controller has noticed a Helm release custom resource, a Helm release object has been created, and it's acted on that to create our application. And you can see the pod info pod running in the cluster. Okay, so that looks pretty good. If I do, I've actually got Helm installed, Helm CLI installed locally here. We're here, and if I do a Helm list, I can see that it's treated just like Helm thinks it's a release as you'd normally expect. There it is, as it's deployed. And if we were to we can actually see whether the application is running as well. So if I come to this top window here, and if I do a port forward, I'm going to do pod info. I think it's 9898 to 9898. And if I visit local host 9898, there's our application running, being served within the cluster. So we know that it's working and everything is good. Okay, so now what if we wanted to make a change? Because obviously we've got our application installed and everything's all good. Perhaps there might be a change in the chart, might go to a new version, or if it wasn't a Helm chart and it was just Kubernetes manifests or a customized overlay or whatever, maybe we've applied some new changes. We've sent those up to GitHub. How do we actually go about making those changes and making sure that they appear within our cluster, all without touching the cluster ourselves by using Helm upgrade or kubectl apply or whatever? Well, we can affect that again. I mean, remember that GitOps is there, or the agents are there to actually do this on our behalf. So we can simulate a change. And what I'm going to do is I'm just simply going to edit one of these manifests, will be the Helm release manifest locally here. And what I'm going to do is just add in something at the end here. And I'm just going to change the values, or one of the values for the chart, just so that it generates a new version for our application. So if I change the replicas from 1 to 5, I think that's definitely not all right. Okay, I think that should do. I think that's correct. Okay, so basically I'm changing the Helm release definition, and I'm just making a trivial change here, increasing the replica count to 5, and we'll see what happens. So we've made that change locally. We can stage that change. Whoops. I'll just put something like that, change replicas to 5. Not very good commit message, but you get the drift here. And then if I push that, so that should now be in our change, should be reflected here. And it is down the bottom here, we've got the values changed to 5. And as you can see on the left-hand screen here, you can see, again, without typing Helm upgrade or kubectl apply, whatever, the change has been picked up by the source controller. It's been applied to the cluster by the customized controller. The Helm controller has noticed the change in the Helm release, and the change has been applied to the cluster, and we now got 5 replicas running inside the cluster itself. Okay, and if we did a Helm history on pod info, we can see there's 2 revisions here. So we can see that the Helm thinks that there's naturally that there has been an update, an upgrade. So there's a new revision that's been deployed into the cluster. So that's basically it. I mean, we've seen things working in a GitOps style. We've bootstrapped our cluster. We've seen how Flux gets to manage itself by monitoring a GitHub repository. We've created some custom resource definitions for our application, a source which tells Flux where to find the Helm repository, where our chart is. We've also created a Helm release, which also defines where to find what chart it is that's going to be retrieved from the Helm repository. One thing I didn't perhaps mention that gets created also in here is as part of the whole process for a Helm release, a Helm chart object gets created as well. This is something that's internal to Flux, so that's another custom resource that gets created by Flux itself. So we can see how we don't actually have to touch anything here. Everything is managed by GitOps, by the agent. We're only interacting with GitHub, and you can imagine here that if we've got CI/CD tooling that does these things on our behalf, then we can apply GitOps at the end of the chain to actually do our continuous delivery for us, or continuous deployment in actual fact. But there's one quick thing I want to just show you. If we were to make an imperative change here, so as I say, I've got Helm installed here, but if I was to run a command, which is effectively me interacting with the cluster in an imperative way, so I'm going to uninstall the release called podinfo. So if I do that, okay, that's gone. You'll see on the left-hand window here, we can see that the application is terminating, as you'd expect it would do, in fact. So what do we think is going to happen? Well, in theory, what should happen here is that our Helm release object is still inside the cluster, and the Helm controller notices that it's there. It interprets that as desired state. It notices that the Helm release hasn't been applied, and so it goes ahead and reinstates the Helm release, and the pods get deployed back into the cluster itself. So this is an example of us trying to make an imperative change. The GitOps operator, Flux in this case, is monitoring the state of the cluster. It also knows about the desired state, and it's done something to try and reconcile that difference as a result, which is super cool. And obviously, this can happen as Argo CD does this exactly the same way that Flux does. So just very briefly, what I'm going to do here, I'm going to actually, I think what I'll do, I'm going to edit this, actually what I'm going to do, sorry. I'm going to remove this file. Info, HR. Okay, so that's gone. I want to make sure that gets reflected back into our GitHub repo. I'll do remove. Sorry about the spelling. You get the gist. Okay, so that change has been pushed to GitHub, and our application should terminate any moment now, because we have removed that Helm release custom resource object. What I've also got running in the cluster here is Argo CD. Okay, in a completely different namespace here. So I'm just going to very quickly, because we're running out of time, I'm just going to show how we can actually get Argo CD to do a similar thing, but all through the graphical user interface rather than through the CLI that I've just been demonstrating to you. So if we port forward I think it's the Argo CD server service. I think that's right. And if we do 8080 and 443, it's going to work. Hopefully it is. Let's go to local host 8080. No, that helps if I put a T there. Okay, so I'm actually logged in anyway at the moment, so that's cool. So this is the user interface for Argo CD, and what I'm going to do is I'm going to create a new app which we'll call podinfo. We're going to give it it's going to be in the default project. The project is a collection of applications. We're going to do automatic syncing, prune resources, and self-heal as well. Repository URL, if we remember correctly, was Stefan Prodan GitHub.io/. Oh, actually, the other thing I need to quickly do is say it's not a Git repository, and it's a Helm repository where the chart is. So hopefully that's the correct one. You can see already that it knows about the pod info chart because it's gone out to that URL to retrieve the information. So I'll select that chart. And if I check the version, it already knows about all the versions that are stored there, all the chart versions. So we'll go for number 6. We're going to be deploying to our local Kubernetes cluster. We'll go for the default namespace. You can see here also it's retrieved a lot of information about all of the chart values that can be changed. We won't worry too much about that. So we'll just hit create. And already you can see the object has been created here. And this is the cool thing about Argo CD is that you get graphically, you get to see everything that gets created. So here you can see the deployment, the service, replica set, etc., etc. There's our pod, and so on and so on. And if we checked over in our cluster over here, we can see pod info is back up and running. This time, courtesy of Argo CD and not Flux. Maybe I can just make a change here to the parameters. And if I change this, again, I'll do what we did before. We'll change the replica count to 5. We'll save that. Okay. Come on. Well, you can see running in the cluster, it's got the 5 pods running. Okay, and then pictorially or graphically, we can also see that there are now 5 pods running in the cluster. So that's Argo CD. If you prefer working through a user interface rather than through a command line, then perhaps it's the correct thing to use. Okay, so that's our demos. That's our demo time. Hopefully you've been able to follow some of that. I suspect maybe you might be able to actually to recreate these things in your own time using the documentation that we've provided at a more leisurely pace. Okay, so almost finish off then. As we are definitely running out of time, I just wanted to mention some of the challenges that you're going to come across. It's not about the technology, okay? That's important, and there's a lot of learning to do, and so on. But relatively speaking, if you've got some good technicians and so on, then the technology you can handle and get a grasp of. But there's a bunch of other things that you've also got to consider before you can be successful with this. Okay, so part of that is defining a workflow that fits the way that you work, your organization. So you're not just going to have one application, you're going to have a whole bunch of applications. You're going to have a whole bunch of different teams, different dev teams, different ops teams. They've all got to work in one way or another. You're probably going to have a lot of different clusters, and this really depends on how you work as an organization. How do you fit all of that into a GitOps setting, or how rather do you get GitOps to handle all of that complexity? That's something that has to be thought about very carefully. Part of that would be to do with the way that you structure your Git repositories if you're using Git. So there is a trade-off between flexibility and complexity. You don't want to hold people up. So your developers, you want to move at maximum speed. They don't want to be waiting on ops people to to allow a particular configuration or whatever it is, that just gets in the way. So this whole self-service scenario is a good thing to have. So you've got to think carefully about how you structure your repos to set that sort of thing up. At the same time, you don't want people that you'd rather not trampling all over your production cluster, making changes, ad hoc changes, etc., etc. You want to be able to have that control. So you have to work out what's the best compromise and the best way to structure stuff. There is no right answer. I'm just saying that right away. It's something that you have to work through as an organization. Handling secrets can be tricky because remember, all configuration theoretically is held in Git. Well, you don't want to, and Kubernetes secrets are encoded in base 64, but really you don't want to be putting those into Git, especially into a public Git repo, because that's trivial to decode. So, there are solutions out there for handling this. There are things like sealed secrets. There's a secrets operator. There's a whole bunch of solutions. You could choose not to use the Git approach or the GitOps approach for these secrets, and you could have something like HashiCorp Vault, and you could have the one part of your workflow reach out to an external service to provide that for you, etc., etc. So that's something that you have to work out and decide upon. And the last thing I'd say is don't underestimate the soft issues. So a lot of this is about technology that we've been talking about, but the soft issues are equally as important. People are used to working in a particular way, so you may come across some hurdles to adoption. People don't want to change, so you're going to have to go through a selling exercise, both with peers, but also with management teams as well, etc., etc. Don't underestimate that, because that can be a very big issue to overcome. Discipline is another thing here, because setting up GitOps, it all looks great working in that way, but as soon as something goes wrong on your production cluster, then perhaps maybe you're thinking, oh, let's just get on that cluster and fix it straight away. And then you're just going to go down this whole route of circumventing the GitOps approach, and you lose discipline. And before you know it, you're back to square one, where your desired state and actual state have converged to a great degree. And then the final one is skills, of course. Okay, there's a lot of technology out there, a lot of things to learn. It's not just the GitOps operators, things like Flux and Argo CD and Jenkins X and things like that. You've got to be familiar with all of the other tooling as well. So your CI tools, and I've already mentioned about the secrets operators, and obviously Kubernetes, maybe Helm, etc., etc. These things are all important as well. So there's a big learning curve, and acquiring those skills and developing them and holding them is difficult. So do make sure that you keep that in mind as well. So it's not all about technology. Soft issues are important. Okay, so that's about it. We've come to almost the end of our time, so let's just briefly look at what we've covered. We've taken a bird's eye view of what GitOps is, where it came from, the problems that it's trying to solve. We've looked at a couple of the key technologies, and as I've said, there's more out there. We've seen a practical demo of GitOps in action, and we've seen that there are some challenges to overcome as well. Okay, Thomas, I think I'm going to hand back to you for the next couple of slides, which talks a little bit more from a CS perspective. Is that okay?
Yes. Yeah.
Thank you.
Thank you very much. Thank you all for listening. So we have a couple of resources more for you. So we have our own page about GitOps on our website, which is just linked in the chat. We also have an ebook. If you good next slide. Written by our consultants, Ian Meal. It's a whole book. You can download it and read everything about it, also about experiences with GitOps, and yeah, more importantly, next slide, please. We would also like your feedback for. Sorry.
We were just going to say there is a course.
Yes, we have a workshop. I think the date here is not correct with December 2020, but we are offering Essentials workshop, which is 2 days, and so for half day, so it can also be stretched out to 4 days or something like that. And we're going to cover what we just covered today, but a lot more, and go a lot more in depth and a lot more practical with practical hands-on experiences. So after that, someone was really equipped to know about GitOps. Yeah, that's what we have. Now we want something from you, which is your feedback. So I'm going to post this also in the chat. It's really important for us that you give us honest feedback to this session, so we can improve and make future sessions better for everyone. That's how we work, and it's much appreciated.
Yeah.
And yeah, then also we do modern GitOps, we do other things, and you can read about that on our social medias. Also, Natural is tweeting, and also you can read our blog where we write about GitOps and a lot more other topics as well, all around cloud native technologies, but also cultural changes, psychological safety, among other things. Yeah, then thank you for joining us, and hope you had fun, hope you learned something. And yeah, if anyone has any questions, then I think now's the time, or we can just have an open discussion about experiences. And yeah, thank you for being here.
Yeah, thank you.
Oh, it throws a 404. Okay.
Does it need a www in front of it? I think there might be a redirect.
Yeah. Anyone, any questions in the meantime? For security, we probably have a couple things in our blog. I don't think anything comes out of on the top of my head. We do security as CS2 at clients, like things with open policy agent and stuff like that, or setting up the whole IAM structure. But we don't necessarily have a complete security section. I think we should have, actually, because it's an interesting topic, an important one.
Maybe we can find something else and respond offline to Shashank.
Yeah, we have a couple of security posts, blog posts on our website.
I have a question, actually. Well, operational teams being on the, non-familiar side of to the, Git tools. What is the learning curve for them? It's basically cultural thing as well, as you mentioned.
Yeah, I mean, I would say that because whilst I think I said during the course that Git isn't necessarily part of the principle, if you like, of GitOps, in practice it is. And I think pretty much you'll need to know Git to be able to work with GitOps properly.
At least the paradigm, I mean,
yeah.
they have their script somewhere like forever, but now they will have to change the paradigm, like getting closer to the development life cycle, right?
Yeah, totally. Yeah, agreed. I think, I mean, I guess ops has been moving in that direction for some time anyway, I would think. I mean, it's probably reasonably rare maybe to find ops people who don't code, who don't at least have a little bit of understanding of how to work with or interact with Git. I mean, I'm one of those people, in fact. I mean, I'm not a developer per se. My background originally was in ops, but I have a little bit of Git knowledge and experience. And I think once you've got it and you've picked it up, then I think you're able to work with GitOps reasonably well.
It can actually, working at clients, it was actually quite interesting that the GitOps process can involve more people than before within that process. Especially before it gets applied to the cluster. There's usually the classic one are the pull requests, but there can be other steps as well where non-technical people can also have a look at, for example, I had a case where security policies were usually done with asynchronous communication channels.
It's more transparent, right?
Yeah, and then now we can include all those configuration all in the process, and they can. Then we just add another step in the process to get into a cluster, and they can then check it off and have it checked, and then it moves on to the next phase without them understanding anything else about the whole process.
I think it can work the other way as a disadvantage as well, because I think if an organization has got some very well-defined and historical processes that involve change management. I'm thinking about ITIL and stuff like this, where they have change management boards and all that kind of stuff. Trying to persuade people they should start looking at pull requests and stuff like that is a bit of a cultural change.
It depends on the company as well, I guess. I mean, the culture and their background.
Yeah, totally.
Thank you. That was a great session.
Okay, good.
It was very helpful for me.
Good.